Hello everyone, welcome to my channel all about mechanical engineering. Today we will have another question on projection of lines. An example in which front view and top view positions of both ends of the line are given and inclination of the line with horizontal and vertical plane are to be found out. Before moving ahead to the question, if you are new to my channel, make sure you have subscribed it so you don't miss any of the upcoming videos. If you like the video, like and share it with your friends. Let's take an example. A line PQ of 70 mm length has its end P 15 mm above HP and 15 mm in front of VP, while the other end Q is 40 mm above HP and 60 mm in front of VP. Draw the projections of the line and determine the inclination of the line with HP and VP. Let's extract the given data first. Line is given as PQ, true length is 70 mm. Front view and top view positions of point P is given, that is 15 mm above HP and 15 mm in front of VP. Front view and top view positions of endpoint Q are also mentioned, that is 40 mm above HP and 60 mm in front of VP. What is required to be found? Inclination with HP, that is theta, and inclination with VP, that is phi. Now let's put this given data on this solution in order to understand how you have to proceed in order to obtain the final answer. So we have front view and top view positions of endpoint P, so this is known to us, and front view and top view positions of Q are also given, so we have these two positions as well. But the problem is we don't know the distance between these 2 points and these 2 points. So this horizontal distance is not known, because of which we cannot directly obtain this front view and this top view. So what you have to do, once you have this distance and this distance available, that is, this is mentioned as 40 and this is mentioned as 60, we can draw the locus parallel to xy at the given distance. Once we can draw the locus, you have the true length with you. Taking 70 mm in your compass, keeping compass at this front view position of point P and cutting it on this locus, you will obtain this point. Once you obtain this point, you can draw a vertical projector, and then simply by keeping the compass at this top view location and taking distance from this point to this, you can rotate it down up to the required locus and this top view can be found out. Similarly, you can keep your compass here and you can cut this point from where you have to project it up, and then you can rotate it on the required locus and the final front view can be obtained. Now let's solve it. Keeping this as a reference, starting with the first XY line, drawing a vertical projector, taking 15 mm above P dash and 15 mm below as top view point P. Then taking 40 mm above from XY line, drawing a locus. This locus will be of Q in front view. Taking 60 mm below XY line, drawing another locus parallel to XY, locus of Q in top view. Then taking 70 mm in your compass, keeping compass on P dash, cutting an arc, obtaining the point. So the point name will be here. Corresponding to this, it will be named as Q1 dash, joining it. Then keeping compass on P and cutting an arc with the same 70 mm in the compass, and the name of the point will be Q2 corresponding to this, joining it. Then you have to project this point from here to opposite points top view like this up to P, and corresponding name will be there, that is Q1. Then this will be projected up to opposite points front view, so it is up to this point, corresponding name will be Q2 dash. Now keeping compass on P dash, distance in compass as P dash up to q2 dash and rotating it above, obtaining final front view point q dash and joining it. This is your final front view. Similarly, keeping the compass at P, taking distance as P to Q1 and rotating it on the locus of Q in top view, obtaining final top view point Q and joining P to Q. Once you have done this, in order to check whether you have drawn the correct solution, parallel to this projector of P on which P dash and P are lying, draw another vertical line from Q dash. If you have drawn everything correct, you will get Q dash and Q on a single vertical line which is parallel to projector of P. Once you have obtained this, these are the required angles theta and phi, which is the final answer for this question. Hope you have enjoyed the video. Thank you for watching.